and welcome to ISC Talks, the podcast that keeps you informed, inspired, and ready for academic success. In today's episode, we'll be exploring the frontiers of dental research. Science in dental research in Latvia is advancing at rapid speed, with innovative projects shaping the future of stomatology. Today, you'll hear about the latest scientific developments, focusing on biomaterials, their applications in oral and maxillofacial surgery, and the opportunities for students to engage in cutting-edge research. One of the key initiatives in this field, in stomatology research, is the Baltic Biomaterials Center of Excellence, a project aimed at advancing biomaterials research at an international level. Additionally, this year marks a special milestone in Crown It, the ISC dental case competition taking place for the first time in Riga. This event provides dental students with a unique platform to showcase their clinical experience, problem-solving skills, and innovative approaches to complex cases. So today, to answer all of my questions about dental science and innovations, we are joined by experts from different areas in stomatology and biomaterials research. So to start off, we have Ingus Arnolds Apse, a trainee in oral and maxillofacial surgery residency program. And Ingus was also the last year's mentor in the Dental Students Research Group. Then we have Oskars Radziņš, who is the medical engineer for the newly opened Baltic's Biomaterials Center of Excellence. Congratulations on the unveiling.
Pleasure to be here.
And then we have Līna Ņikitina, a dental student who is also a project director of the board of Latvian Dental Students Association.
Hello.
Thank you guys for joining us. Today they will share their insights on the latest breakthroughs, their experiences in research, and the potential career paths for young dental professionals interested in scientific innovation. Okay, so I'm ready to ask you questions. Are you ready to answer?
Whenever you are.
Let's start off with the current state of dental research in Latvia. What would you say are the key areas of research right now in Latvian stomatology research? Yes. What you're focusing on?
I can vaguely say what I know from different fields of stomatology and oral maxillofacial surgery, where some of our experts are involved in. So let's start with therapy part. We have the chance to be the presence of Professor Sergio Ribe, who is with his wife Maldup, is going aggressively in caries research and whether or not to treat some things, and how to advance prophylactic parts in stomatology, because we all know that stomatology is very expensive. So how do we spend less money by being more aggressive in prophylactic approaches, right? So let's go for example, oral surgery. We have Doctors Mikus Lēnieks. He has very good results in tooth transplantation, and he's now going all around the world. It's his PhD project. He's going all around the world. He was in Chile like a month ago.
December.
Yeah, in December, and for 2 months, and I think he's making groundbreaking research. One might say one of the new specialists in the world in specifically that narrow field.
That's cool.
What else do we have?
We pretty much already mentioned a few BBC contributees, because, for example, you already mentioned Professor Ilze Maldupa, but she does a lot of work, especially in with children, preventing dental caries, specifically in children. Her husband, Sergio, he does a very broad spectrum. He's very orientated in like dental, like teaching dental things in general for like students, how to improve the teaching process. He also dabbles a little bit in like AI and large language models. So how that changes the training scheme for everything for students. Like how do you have to adapt all your teaching materials now that all these tools are in place? Like how can they be used in dental training, and are they applicable in actual practice, etc. So he dabbles into that as well. As Mix mentioned, as Ingus mentioned, like Mix as well. I spoke to him a little bit and like on his PhD. Technically, he's not like the very, very first. He's kind of picked up it using like new tech that we've kind of had in place due to BBC, like getting all the infrastructure in. Because originally he was looking like the literature reviews and everything, like people used to auto-transplant teeth, but that was like a couple of decades ago.
Okay, so he just made it better and new.
Yeah, because basically he's not like the pioneer. He said there was like a surgeon like in the previous generation that used to do that, but for some reason stopped. And he just basically picked up where all the experience was gathered and just started building up on top of it.
Was the previous surgeon's experience positive? Did it work out for him?
I believe so, but it was kind of like a whole stigma shift because basically, how should I put this? Greed. Because basically putting in implants gives you a little bit more extra money than actually auto-transplanting the tooth.
That is
because when you're auto-transplanting teeth, there's always the risk that it might not, because all the teeth you auto-transplants, the root is not formed for it. So it needs to basically fix into the new position, it needs to get blood flow, it needs to, stem cells to differentiate, it needs to grow. And it's not always a complete 100% guarantee. If he has good results, it's like, I don't know, 95% success-wise, but it's not 100%. And it's basically, there's a little slightly more risk involved. What he's doing is good because most of his patients are kind of like adolescent age. They're like not fully matured, so they're kind of in that phase, and you don't really want to put an implant in a teenager.
Yeah, it's still growing, very developing.
Yeah, that poses other risks. So technically, in the broad spectrum, using your own materials, being like autologous bone, is always the best case, but it's not always applicable if we're talking about traumas and stuff like that. That's separate. What I would like to give a shout out to Professor Sergio Ryba as well, because it's a common consensus. It's like a different perspective thing. Quite often, whenever you go into research and if you're doing like clinical science on the Latvian population, your reviewers for scientific publications often say your sample size is too small, you need more patients, you're very limited with the Latvian population. But you should always look on like the upside of it, because yes, it's true, we have a very limited population, but then again, you can do broad spectrum studies on this because you can get good results representative of the entire population. Because let's be honest, like doing a broad population study in Latvia is about 10 times easier than doing like a broad population study in New York, which is a city. Yeah. It's like the populations are not comparable.
It's the same as Iceland did. Iceland was at one point, I think, when I read, was genome-wide project leaders because
almost everyone got involved.
Because everyone had to do a genome sequencing, right? So they were leaders of genome-wide.
So it's the same things, like technically we have the potential, we just need someone to go into that direction. Like Estonia is one of the most digitally advanced nations. They're smaller than us, but because they're so small, it's easier to integrate all the tech.
Yes, so what would you think are the key areas? Do you have anything to add?
Speaking from the dental student point of view, I think there's a lot of projects going on in orthodontics. For example, my peer is currently working with you, Oskars, on one of the projects.
What's the peer's name?
Julia. So she's working on a project regarding the scan and CBCT.
Okay, all overlapping.
Together.
Yeah. Okay.
Yes, overlapping, and that may be really interesting as well.
Yeah, you talked about children's teeth, and you also had a project with the new mothers, right?
Yes, but I don't think it's really research related.
Well, yeah.
Even though we are trying to include all of the information that we are trying to include should be evidence-based.
Yeah.
But yeah,
It was there.
I think
was
that what you're seeing in research and always will be seeing, in my opinion, is whenever something new comes in, there's this spike in a trend of that specific theme, and then suddenly like disappears for some years.
The interest dies out.
AI bubble.
No, like for example, AI bubble. I don't know if it will be like that, but anyway, let's see from for example, tooth transplantation perspective. It spiked, disappeared, maybe the implant reason, possibly the implant reason, probably money, and then again there was somebody who picked it up, and that one researcher can actually build up the confidence for other doctors to start doing it, as we are doing it in the institute, right? Mikus is giving us, me for example, the confidence and to do it, and it's already turning into a very everyday case kind of treatment, right? It's the same with subperiosteal implants. They were very popular in 80s and 90s, and then they disappeared because there were some technological insufficiencies, right? And now they are regaining its popularity because titanium sintering is with much higher quality, and new printers are being developed.
Ingus, I would like to ask about the cost-effective analysis of autotransplantation. You mentioned that implants cost more money, or did I pick it up wrong?
Oh,
What actually is
as Oskar suggested that tooth transplantation lost its interest probably because that was the time when implants gained interest and doctors understood how much money you can earn from implants.
Yeah.
Right, and also tooth transplantation is. Most of the patients are paid by the government, and government is of course paying much less money. If you're asking patients, for example, to pay for themselves about tooth transplantation, implants are much more expensive.
Really?
Much
than
more.
Autotransplantation surgery?
Autotransplantation is like.
That's why it's basically on preteens, because for an adult you don't really have an extra tooth to autotransplant. Because you will get your like 8th tooth, wisdom tooth, whatever, removed eventually at some point.
Maybe you were asking too less of money. Maybe in other parts of the world people are.
Because I thought that autotransplantation is much more pricey than implant surgery.
I would not think. I would
No.
not
Well,
suggest-
that's-
I mean,
that's
I
like
don't do this, but
2
I
to
would
3
not expect
times
that.
less expensive.
Really? That's news. Okay.
That's
That-
good.
I didn't
Because
know this.
also, technically, there is no cost-benefit analysis because there's not sufficient data for this, for starters.
It's still too new, right?
Kind of bringing in old stuff that's new now, apparently. Other things, just from a like biological standpoint, your body will function better with your own tissue than with foreign body. So technically, in the long term, if an auto-transplanted tooth should act better than an implant.
So
Assuming
how come it
decent
costs
hygiene,
less?
of course.
Okay.
How come it costs less? Because I think there's more procedures involved getting the
I
already
think
tissue.
it's lobby and all the implant companies and stuff like that. But we're now going away from research part and now going into the business part.
cost. Yes.
I'd like to roll back a little bit on the research part, because there's one thing on the research spectrum I did not mention, which is not necessarily a Latvian thing, but it's more like a global thing that Ingus touched on as well. A lot of the research and actually treatment-wise goes into the type of like preventing things before they actually happen. It's kind of like preventive medicine instead of treatment.
Yeah.
Because if technically from a cost-benefit analysis, as soon as that someone needs some treatment, it's going to cost up like 10, 20 times more if you can prevent it initially.
Yeah. It's better to maybe solve an issue before it's arised.
Yeah.
Before it's an issue.
Unfortunately,
but-
human beings do not function that way. As they say, a smart person learns from someone else's mistakes, a normal person learns from his own mistakes. So
So about research in specifically Latvia, how has Latvia positioned itself in the global landscape of dental research? And maybe there are some particular strengths that make Latvian research special?
Auto transplantation. We already kind of covered
I
this.
think
Is it
that,
the only thing though?
No.
I think that Baltic Biomaterials Center of Excellence is totally like good standing point of how we are gaining popularity in research all over. With help of medical engineers, for example, Oskars, we are very closely working together. We are planning potential reconstructions and stuff like that, how it would look, and analyzing different type of stuff for the future surgeries. And of course, I can't stress this enough, how much popularity of Latvian research I think has Professor Sergei Uribe influenced. It's not a paid commercial. It's just an honest opinion.
And in their circles, it's kind of like a publication machine, basically. And the more you publish, the more you get your name out there, the more like promotion you get.
It's some quality stuff.
Yeah.
It's not just putting some publications out there.
'Cause
It's like
that's different. He usually does like high quality journals as well. Like for example, as Ingus already mentioned, like Mix went to Chile for like 2 months. He toured universities, gave a few talks on like what he's been doing. Not the first time, he's been to other places as well. Sergio has more or less done that for like a couple of years now. Every now and then, he's like also like reviewer in some journals, so that kind of also gets the name out there. So yeah.
Okay, so about the BBCE, the
Baltic.
Baltic Biomaterials Center of Excellence.
It's a
What
mouthful.
is it? What is it that you do there? What are your primary goals?
Right.
what do we do?
I've practiced this spiel for a long time. I usually give this intro like every couple of months to someone.
It's completely fresh.
For starters, the project has been ongoing for over 5 years now, by
Oh.
the way. Yes. Actually, this is year number 6, I believe. And they only just opened the new building in Ņikitina. That's why you probably heard of it more. But essentially, it's based as it's a Horizon 2020 project. Originally, it was supposed to be 5 years. Then they gave an extension for an additional 2. There's a total of 4 partners in the project. And the whole idea is that we kind of improve scientific excellence, improve research efficacy, and kind of build like the pipeline, starting off from developing materials in the lab and putting it all the way to the clinics. So we have Riga Technical University, which is like basically the core partner. That's where the headquarters are stated at. Then we have Riga Radziņš University. We have Latvian Institute of Organic Synthesis. And then we have the Riga Radziņš University Institute of Stomatology, which is like at the very end where I'm at. It's like once everything's ready, then we do all the clinical stuff and clinical trials, etc. So primarily we work for developing of the pipeline, starting from anywhere from like new material development, new biomaterial development, existing biomaterial testing, in vitro tests, in situ tests, animal model tests. Specifically, like the RSU team is highly focused on like biological materials, specifically like from Latvian plants. I believe they've done some research on like Latvian honey effects. Dandelions, I don't remember what else. I'm not a botanics guy pretty much. And then for the final part, which is like on the clinical part, which I do, basically through the project, we have like research infrastructure, we have like 3D printers, we have micro CT scanners. So essentially like once we get to a point where we have finalized the pipeline, we develop a material, we've done all the biocompatibility testing, it seems to be safe, then we can adapt it to any type of manufacturing procedure, specifically like 3D printing is what we do. And then basically get to the shape, get it to the intended purpose, and then start looking for clinical trial applicability.
That's good.
It's a very broad range, and it's a very cross expertise team. As I mentioned, I've not done medicine. I am a medical engineer, but most of my studies have been like biology, so I know like basic anatomy, some neuroscience, but not that much into detail. Then we have people who are are basically pure material scientists. So they know how to synthesize materials, like proper proportions, how much do you need like calcium phosphates. There's like multiple phases for it. Depending on what the phases are like, the name changes, and that always goes over my head. Then we have people who are, for example, one RTU team is very into like metabolomics. Probably, I think you might have a question on this later, but to put it simply, last time I heard they have like a little project / spin-off happening in collaboration with Children University Clinical Hospital, where they basically do like for newborn children. So they use sweat for analysis instead of using blood samples. So that's like a metabolomics thing. Because apparently like the sweat samples, if you know what you're looking for, it can represent about like 90% of what you're after. So you don't need to draw blood from freshly born infants. Especially with like small blood volumes, there's some risks involved into that as well.
Small veins too.
Yeah, and additional shout outs I'm kind of compulsory to give. We don't just do everything like, how should I put this? Everything ourselves. So we have like additional partners.
So outsourcing.
Like, they kind of, it's not outsourcing, but they kind of like overlooking and giving us their expertise and their knowledge. So it's the AO Foundation, which is based in Davos, Switzerland. And then we also have, I don't remember the university's full name, but it's in Erlangen. I think it's FAU, but I don't remember what the whole thing was. But basically, they're like the experts in like the FAU is the experts in the biomaterials field. Like one of the key leaders there is like one of the world experts in bioglass. And then for the AO Research Foundation, they're more on like the prepping everything and doing like animal models and doing like proper research on like cell tissues and materials as well. So that they're kind of like giving their knowledge and then transferring it to us, and then they give us like heads up, you're doing this well, you should be doing this better, this is what you're lacking, this is what you're excelling at, etc.
So about the BBCE and specifically about dental research, does it have like special program for dental and oral or maxillofacial surgery?
In my opinion, even before BBC, all of us, all surgeons, researchers, and people involved in departments were always accepting students, and we are popularizing students and saying, do research, right? Come to us with ideas and get yourselves involved with, right? But BBC coming into the picture, I think it's much more emphasized right now. There's bigger and bigger team of medical engineers. It's like my everyday is usually like consulting a patient, understanding, oh, there's a defect there, this should be analyzed, right? First floor, going to Oskars, let's see what are the possible options, like what are the treatment options, and analyzing in 3D and stuff like that. Yeah, and of course all the infrastructure can be also used by the students, right?
Probably through me, yes.
Or through Mills and
yeah, and then she'll probably just forward them to me anyway. So yeah, if you want to use some of that, it's plausible, but then you most likely will have to go through me. I'm forthcoming. I'm nice. I work with students, probably more than I should.
Always nice people say that they're nice, right?
Hey, you need to promote yourself. No one else will say that, so you have to say it yourself.
So basically with the BBC, the team is bigger, the equipment is better, it's more advanced, but the projects continue.
I'd say yeah. Yeah. Sometimes they might swap. Like you already spoke, Dr. Mix Lennox. He started through the BBC project as a PhD student. That's how it all started off. The thing is, I might boast a little bit. I'm very proud of him because when he started, he didn't have much of an understanding what research was. He had, how should I put this? He was more like a practitioner
He was totally a practical
He was a
guy.
complete practitioner. There was almost not a lick of science in his system.
Now he's
Now
saying,
he actually understands what it means.
now he's saying every day I spend at least 1 or 2 hours for research.
He doesn't specify what
Inspiring.
kind of research, but yeah, because he started off without not knowing really anything how research functions. Like, not how do you gather data, that you need it structured, like what does actually entail writing a scientific article, that you can't just take like, you know, every single patient into the clinic and then just build a database and let's go, it's publishable. That's not how it functions.
Not it.
But,
Yeah,
but I mean, this is the issue that dental students face every day. We don't really know what research is.
That's not just dental students. That's the majority of students.
That's
in
also
general.
medical
And
students.
You know how I
it's a
started?
pity because I think that dental students are the most stubborn students ever. And it's really tough to encourage them to participate in research. And that's why also our student associations is trying so hard to
I
encourage
think
them
that
in every possible
I may
way.
disagree with that. I don't think that they don't want to participate or they're stubborn to participate. I would say that they don't see the value in participating in research because in a lot of cases, dentistry is a very practical profession where you come in, you study, you learn how to be a dentist, and then you go and be a dentist, right?
And you earn money.
And you earn money, right? And that's okay. And that's why the output of dentistry is a lot lower than output in medical professions, right?
I don't really agree because you need to use the best possible materials in order to earn, and you need to, and in order to do that, you need to go through pages and pages of researches, because in order to choose the best possible procedure, you need some kind of background. And you cannot do it without
I would
without
agree
like
with you, but
investing
there are
in
also
research.
courses that say that to you, and you don't have to do research.
Just on a little side note, that if you want to use the best material, then the question is, can you afford it? That is very often that the best things out there is not always affordable.
But that's the thing.
And then you
we
have to
should always-
compromise and pick something else. That's a little sidetrack. I'd like
it's
to
a little
kind
bit
of.
depressing, you know. I think but
Well,
we should
it's not
always,
the States.
We should always aim for the stars. You know?
Yeah.
We
Yeah,
are,
that's
at
the
least,
best
I
thing.
would say that we are always motivated, and I think that there's so many options to do to where to get involved, right? And more, proportionally more and more students are showing interest, and I think it's gaining. Research in every different field in dentistry in RSU is gaining popularity in research way, in my opinion, right? I started in research by just going in in first year. I just started to pick up patients' charts and okay, my dad owned the clinic, right? But
That's
Nepotism there, isn't it?
but I just after, of course, ethics committee, I picked up data, and only 4 years ago I published that study. It's like 7 years passed because before I decided that, okay, I need to finish this, right? And after that, after I started and after I gained the momentum. Before I published my first study, I already published 4 different studies in journals because I then went to Professor Skorniev's and we did basal cell carcinoma study. Then I got to be part of University of Birmingham project, which was a huge project all over the world and is now involved in those studies were used in up-to-date guidelines for COVID surgery patient prophylactic regimes and stuff like that. So yeah, I think that when student starts, usually the momentum is gained. It's like,
Oh, I can.
You know-
I can go against this so well.
You know, the main problem.
I mean momentum, okay?
The main problem in my experience with science is like taking practical steps, because you mentioned that you went through patient charts right? And but the thing is, how do you get through ethics committee? Because it's not easy to do as well.
It's much easier than you think.
Is
It's
it?
not.
Yeah.
Maybe
I don't
should
think it
contact
is.
you.
Not that easy.
In my opinion, it's very easy. If you're clearly
Maybe you just
stating
had a
your-
lucky case.
few lucky ones. All of my ethics committee protocols went through in 1 month. Everything.
That was a long time ago. The ethics committee's changed.
Yeah,
It's
it's
different
been
now.
changed now. They're a lot
1.5
more
years
strict.
ago, I also did. It took 1.5 months. I don't know.
Maybe they just see your name and they're like, fine, take it.
No, I think
yeah,
that
we already know him.
We're
He's
talking
good.
more about there's more problems than solutions. But in my opinion, it's just if you do it, then you're if you just go with like enthusiasm, you will eventually get there.
Anyway, I want to say my piece. You said when you go to the Mentum and get rolling. Just to share personal experiences, my first research experience is my own final year master's project. After I finished that, I was like, I'm never touching science and research with a 10-foot pole again in my life. It was that bad. And that I was good at science. I didn't want to do it anymore because the experience was terrible.
Second, remember that we have to motivate people
We have
to do
promote
science.
it.
I know where I'm going with this.
We have to get students into science.
Yeah, I'm actually doing a lot of science these days. I'm just saying like where I started because I got extremely demotivated. Then I started working here. I got recruited into the project, and basically I just started working with people and I started contributing to science.
Did you get some enthusiasm from working in it?
I just got
Like
kind of
gratification?
because I knew I was kind of good at it, so I might as well help them. And it's like that. Then the momentum starts building up. The point I'm trying to sell here is the first experience can be very sour, but doesn't mean it has to always be like that. Because for students specifically, if they want to go into science, because I also I am a mentor in one a research group for students. And it's kind of meant towards research, but they don't really do research up to this point. The thing is that most of them want to do research, but they don't know how. They don't know where to go, who to talk to. My advice is just pester your lecturers, pester whoever teaches you practical parts or whatever. They will have some experience or will know someone else who's doing research to some degree. I didn't study in Latvia, so I studied in the UK, so it's a little different. For me, when I tried to get some research experience before doing my master's, I actually had through the university capabilities. They just had on the university website, this researcher has a placement for this research project during the summer
So you
for
could
3
just
months. So
apply.
you could just go for a list, write up your CV, send it in, and cross your fingers.
I 100% most of the RSU students don't know that. But in RSU, that's also a thing.
See, I didn't know that.
It is.
Yeah,
You can
there
apply
are
for
lists
PhD
of,
students.
There are a list of projects where you can be part of research. I think it's just all over the world. It's the problem of taking the first step. Everybody's talking about I want to do science, but are not willing to write the first email.
Yeah, it's scary. Because if they actually accept you, you actually have to do something.
The question is, what if they say no? And that's the question everybody's
just
asking.
apply again. It's the same thing once you go into workforce.
What if they say no? Nothing's going to happen.
You're just going to have a free summer.
Yeah, just write to another professor.
That's why you don't apply for a single place. You apply for 120.
Yeah.
One of them is bound to give you a yes.
And suddenly you have 120 projects.
And you just pick your favorite one because apparently you're in demand.
Yeah. So actually about Latvian Dentistry Students Association, I wanted to ask you, what does the association do to help students to apply for science? And maybe do you provide some kind of mentoring or networking?
So last year we organized a beautiful event, which was a LZSA research event, where we invited dental professionals to talk about their experience in science. And it was so inspiring to see so many faces and so many people interested in doing science. Yeah. And this event basically was the networking event for them. If they thought that a lecturer was working in a field that the student was interested in, they could always approach them and maybe talk about potential collaboration. One of the things that we also do is collaborate with the Riga Radziņš University Stomatology interest group. And so basically the interest group works like that. Members of this group create presentations about a specific topic that is science and evidence-based, and we transform those presentations into posts so that dental students, dentists, and pretty much everyone who follows us can see and learn something from it. And one of the things that we also can provide, there are a lot of international dental research programs, and students from Latvia can apply to those programs. Basically, a group of students go to a certain place where they complete a project.
So you're basically making the list where to apply for.
Not really. So we are a part of International Association of Dental Students, and they provide us with application form. For example, the program that will happen soon is in Pakistan. So Latvian dental students can apply to this specific program.
Is there a lot of engagement in these programs?
Yes, of course, but not from Latvian dental students, unfortunately.
Come on.
From every
You
other
have such
international
options.
students, yes, but Latvian dental students are not active, in my opinion, and we're doing our best to change it. But
Why do you think
it's a
that
tough
is?
journey. I don't really know. Maybe dental school is challenging, and the thing that is really specific to dental students, we're trying to volunteer from year 1 or year 2, and it takes time as well.
Yeah.
Therefore,
All of the process is very time consuming.
Therefore,
But then
we
again,
don't
they're
really
going
have free
into
time.
practical working, less research. It's kind of like a circle.
It is. And it's really tough to break it. It's really
Jeez.
tough. And our current scientific officer, Laura, which is also the head coordinator of International Student Conference, she is working on creating a scientific journal, the Dental Scientific Journal, that is completed by students. So maybe Dr. Ingus and Oskars will help us in the future. Maybe.
I had some experience in first year of medical studies. So I started with medicine, and in third year I started parallel studying dentistry.
As many do.
I think in first year I started the journal Semper Anticus.
Yes.
And I don't know what's the status of that. I recently saw
It's still going. It's going strong.
It's super.
We had a podcast episode about that one too.
Oh, nice. Nice to hear that. Yeah, and I saw actually recently, I looked it up, the issues, and they're getting better, and they're getting more with more quality and stuff like that. And I think that if something is already made for example, a good base or Semper Anticus dental or whatever is where already team is a good start, possibly, right? Maybe think about that. I haven't been in contact with the Semper Anticus team for years, and actually I don't know what's the team like. Yeah,
It's very good.
it's nice
They're really revitalizing the journal.
It was, in my opinion, it was very hard to put out so many issues as student parliament wanted. It was like at first we are speaking about 4 issues a year.
That's a lot.
That it was incredibly hard to even make one.
Yeah.
Yeah, and
Now it's 1 issue a year. Yes, that's a different episode. Okay, so getting back to dental and research. What are the most promising future developments in dental biomaterials? Something that...
Can you repeat, please?
What are the most promising future developments in dental biomaterials?
3D technologies and AI right now,
Okay,
in my opinion.
elaborate on that one. That sounds so
That's a
interesting.
topical thing.
But
Nothing
Isn't it?
new has really showed up. Well,
But
you never
isn't
know.
it-
You could always develop a new material that's magically better than anything else.
Yeah, but for example, it's not. It's more of a laboratory researcher kind of.
Okay, fair. I get your
right?
point. It's just more like
from
a
from my
practice
from
point.
my from what I can see as a clinician is the groundbreaking stuff is something that can heal the patients that I'm treating, right, or help them, right, and AI helps to do faster diagnosis, to analyze radiographs. In the future, even maybe to search faster for specific doses of medication, because there are thousands and nobody expects doctors. I hope nobody expects doctors to know all the medication doses.
Hey, what are you studying 6 years for?
and all the AI is already being used to search for symptoms and maybe give possible pathologies. What could patient be sick with? And 3D technology is in a way that in reconstruction, right? We are already ordering from other countries the printed materials and reconstructing patients. So
Okay, that's something that you could use in like everyday practice also.
we already are doing that.
That's
yeah. 2 days ago.
I don't know. That was your patient.
Or yesterday. No, 2 days ago, I did a reconstruction after actually a dentition. So you know what is a hypochlorite crash, right? Where you spill out material, endodontic rinsing material outside the root, and it's very toxic for the bone, and it causes atrophy. And the patient, after 2 years, the patient came to me and he had atrophy of anterior wall of maxillary sinus, leading to asymmetrical face, right? So we did the reconstruction also with the help of medical engineers to plan it, right? And put the implant in. And now the patient is symmetrical. Of course, it's still early. It's only a few days, but these things are. The surgery time was basically 30 to 40 minutes. The planning part was the biggest part, right? And the team part that was involved.
The planning is the reason why it takes you 30, 40 minutes. You're
Exactly.
welcome.
Yeah.
I'm saying that.
On other aspects, specifically to biomaterials, AI, same thing. Potentially, yes. Practically, we'll see how it develops. Same thing is like just how it discovers on occasion new proteins that have never been seen before. In theory,
Yes.
it could, in theory, create new materials. I don't know how it would be with medication, because there's a lot of question marks that can affect it.
I
There's
think there was a publication where new medication was new.
I heard of it, but
There was actually kind of a game that people could play where changing.
That's how they gamify a lot of it, because you need to train a lot of AI.
So
with
they changed
marking
the positions
resources.
of molecules, and even non-researcher could do it.
Okay.
And it led to discovering of new protein that could treat specific illness. So it's practically researchers turned it into the game. I don't know the specifics, but I saw the article and I thought it was awesome.
There's probably multiple on App Store, Google Store. There's actually multiple apps that are games, but they're specifically you as the person who plays it. You're basically marking the data that is then used for AI training. There's multiple ones for that one, because otherwise, if a single person or a group of researchers does that by hand, it literally will take them years.
So you
use
give
the
the
public
monkey the
resources.
typewriter.
So
Essentially.
we are basically researchers are using everyday people that want to play games or whatever on the mobile phone, right? To train their AIs.
Isn't that kind of dangerous that they could come up with something not good? Like
No,
it's good when they find a good protein.
If you do the whole design properly, then that's not a problem.
Okay.
Of course, there's always risks. I'm a bit of an AI skeptic on that regard, but yeah, there's always risks. Other things, specifically are biomaterials. As Ingus mentioned already, 3D printing, it's kind of like, it's been in for a couple of decades now. Specifically in the advancements on that thing is like other types of printing technologies, other types of materials, like one of the things, like there's specifically so far only one way that you can print like biocompatible plastics. That's basically like standard, if you've seen like standard tabletop printers where it prints layer by layer, just pushing it out, it's basically more or less the same principle. Other printing techniques, if you can develop elsewhere, like for example, you can print ceramics through SLA printing, which is basically use an additional material as a binding agent, polymerize it to create a solid body. I'm trying to speak simple terms.
Yeah, it's still difficult.
But that's basically, it's just different ways how you can 3D print things. So you're not just bound to a single type material. There could be someone develops a new tech and all of a sudden you can use materials you currently can't. That's always a possibility. In biomaterial development, recently they started doing the same like 3D printing material that is in like biocompatible plastic, but it's embedded with ceramics. Because most of the plastics, they are more or less bio-inert. So you can put them in the body, you don't have a foreign body reaction, but it doesn't integrate in the long term. If you add, like, let's say about 30% body weight of ceramics into it, it kind of gets like the benefit of the ceramics. So you get some cells grown into the material. So it kind of integrates better into the body.
That's cool.
And that's just like a recent development. This like happened like a year ago, maybe 6 months. I only found out that's an actual thing like a couple of months ago. And there's still active research going on to it, but it's already like clinically applicable from a material standpoint. It's just the question is like the system you're using. And then also on 3D printing, I'm a big opponent to putting like 3D printed parts in a functional environment. If it's not like 3D printed metals like titanium, stainless steel.
Load bearing, right?
Yeah, load bearing applications.
What load bearing means is, for example, what I mentioned before, the surgery that I did was pure aesthetical. So the material doesn't have to be strong. It doesn't have to. Okay, it might be.
There's some minimum limits.
It isn't loaded with forces.
So
right?
it's not under compression. It's not under tension. It's not your elbow joint, knee,
or
hip
jaw,
joint, or
right. For example, when you're chewing,
vertebra.
there's a huge strength put to your jaw, right? If we would use that material that I put it in the cheek, right, it would break apart. Okay.
It's always a risk. So that's like on that side. It's like if you can make like physically stable and strong structures, then you can go beyond that thing. Because in theory, you can use ceramic 3D printing to print like crowns, dental implants, whatever. But they're only good in compression. The second, for example, if you grind your teeth overnight, you won't have much of an implant left.
Yes, of course.
And also, let's not talk about it. It'll probably cost you like 10 times more than the current implant, but that's a different story. Like cost optimization and workflow optimization is like another thing. And then the last thing that's been like, I think centuries on the research part is always like material coatings. So you're often bound, if you use like a single material, you're often bound just like on how it performs on its own. And it always will have some kind of drawbacks. So material coatings is like another thing that's always kind of somewhere on the horizon. Always someone will find something new. Like same thing, if you do like biocompatible plastics, maybe you don't need to embed the ceramics into it because basically you only need ceramics on the outer surface. But if you print it the way the technology works, you have ceramics all the way through the implant. The bone, hard tissues like bone and cells, they're not interested what's happening into the implant. They only care about the topology of the surface. So if you do like some kind of ceramic coating instead, or any type of like, let's say, I believe like titanium oxides, specific compounds are other coatings that you can use just to mitigate the bio-inert effect. So you kind of simulate it to make it bioactive.
It just turned into a lecture, but I'm actually learning.
Would it be possible to maybe make like a spray-on bioceramic coating?
That would
Don't
be
put
that,
this
that
in,
would be a question for a biomaterial scientist because ceramics are kind of like solid. Let's say they can be
Yeah.
more like powder based. Like there is a coating method called like spray coating, but then you need to make it like more of like a liquid, so it needs to flow. Most ceramics are kind of like grain based, so it's kind of difficult. In theory, yes. The question would be how,
That would be cool.
but that's another aspect.
Yes.
50% of listeners are zoom out at this point. Maybe we should.
I think that will actually. I have one last question for you as conference goes. How can students and young professionals make most of the opportunities available in Latvia? And then I'll let you go.
I think the main thing is to be active and don't be afraid of taking the first step. Write this email and write maybe 100 more emails. And maybe at some point you will eventually end up doing some good research.
What was the saying of if you never take a risk, then
You don't risk, you don't win.
yeah.
Yeah, you have to buy
Yeah.
the lottery ticket
You will
to win.
If you don't write that email, if you don't go up to the professor, you will never have the chance to be part of something. That's just it.
And it could be something
You can
very extraordinary.
you can always be the student that sits at the last row and be the cool guy, right? There's nothing cool. It might be cool in high school, but there's nothing cool in being the somebody who doesn't speak, who doesn't take part in discussions, right? It's your career, it's your profession, right? It's not anymore high school.
It's better to be active.
Yeah.
I'd like to echo the sentiment. Contrary to popular belief, being a researcher is a job for extroverts. Because you can be very good with data, but if you can't present your results and you can't talk to other people to get other ideas or give your own opinion, you're not going to get far in that.
Yeah,
As bad as that sounds.
actually those hardcore art really technical university researchers, they're very extrovert. Yeah.
It's kind of like discouraging
it
for
sounds
introverts.
Like it's a thing you can learn. You can be an
Yeah.
introvert, you can learn to be extroverted, and vice versa. But yeah, I'm just echoing the sentiment that you have to take that first step. You have to, reach out, find someone. I can share personal experience with this. There's a certain orthodontics resident who used to be a student, and she just found me when I started working, and we've been collaborating for years on research now. So all you need to find is just that one person who gives you a hand, gives you some guidance. I've had topics like this before, and I kind of draw parallels with like psychologist. Your first mentor is kind of like your first psychologist. You might quite often want to swap a few until you find someone that matches with you. That's kind of like my own personal first research experience. It's not the greatest, but that doesn't mean that you have to be stuck with it. Sometimes for your first experience, you might think you might want to power through it. Okay, more power to you, but to each their own.
Yeah. So all the students wondering about research and wondering about the newest developments should just kind of get started.
Just write that email.
Just apply.
Just write that email.
So yes, again, thank you for putting Oskars and Līna today for joining us. This was very cool.
Thank you very much for introducing. Yeah.
Yes.